Well, hello and welcome to this video presentation. Today we're going to be taking a look at testing asynchronous processes in PHP using the Zend Server Job Queue, which is a feature inside of Zend Server 5, which you can download for free at zend.com. So this is kind of how I do unit testing on easterate.com. So the basic architecture of the Job Queue server is that you have a front-end web server which is actually servicing the requests for the individual customers coming in. That's your regular PHP that you try and get done very quickly. Have your response back in a couple hundredths of a millisecond, or not, a couple tenths of a second, or even a couple of hundred milliseconds is okay. So that's your typical front-end implementation. Now, what you want to do is you want to be able to get that job to a state where it can actually be run separately from the front-end web server, and that's what the job queue is intended to do. It's generally run separately from the front-end web server, because otherwise you can't run things asynchronously. It can run on the same physical server, but it's going to be run inside of an individual HTTP request. So what happens is you make an API call over HTTP to the job queue web server. We'll see an example of what that API looks like. It's actually very simple to implement. But what this does is it allows you to implement your front-end request the way you would normally, but then queue up any kind of long-running task or any kind of task you want to schedule in the future on the job queue like this. So this can be this job queue web server. It's still a web server, but it can be run locally on the individual machine, or you can also have a whole bunch of front-end web servers talking to one job queue web server, or even a load-balanced job queue server if you want to do that. So before we actually get into the programmatic aspect of this, let's take a look at the functional here. This is how I manage a lot of the tasks that I want to run on the easterate website. So for example, you see processing Twitter results or indexing content. This is where content is taken from the blog postings I've made and put into a Lucene search engine. And we have another one here that does Twitter searches. You can see that I'm searching for ZF or Zend Studio, Zend Server, or Zend, or something like that, and it'll run those at appointed times. Now the problem is that this is actually being run completely separate from the front-end application. So because I don't want to be able to have to click on something in order to run it. So for example, if I wanted to run the Twitter search, you can just click on it and then have it run at that point. I want it to run kind of without my not knowledge, but without my having to explicitly tell it to do so. So what I do then is I can go in here and I can select an individual search, and I can type in whatever it is I want it to run in there. And then if I schedule it, it'll run at a later time. But to take a look at that task, we see here that we create a new Zend Service Twitter search, and we create a DB table in ZendDB. We get the last ID, we do a query on it, and basically fetch a new object, populate it, and then save it, which is all well and good, but that's an awful lot of stuff to have running at the for an individual click. So we run it as a queued item in the job queue. But the way we want to test this, though, is actually a little bit different. We'll actually see how that's going to be done in just a moment, but this is the individual task that needs to be run, and also the individual task that needs to be tested. So what this looks like from an API or programmatic standpoint is we need to create an abstract class. I call that ESC task abstract. And that defines a couple of individual methods in there that are important to task execution. The first one is a protected abstract function called _execute. And it receives Zend application as a parameter. If you're using Zend application, that's a good way to get it in. It's not entirely required, but it's something that you can do. Because it's an abstract function or an abstract method, when you want to create a new task, this is the method that needs to be overridden, or actually not overridden, but implemented. This is where your logic for the individual task would go. The next function that needs to be defined in the abstract class is a final function called execute. This is called on the front end web server, and what it does is it creates an instance of the individual API object, or it takes an instance of the API object, or this task abstract object, the one that's actually been instantiated, and it serializes itself. Then what it does is it connects to the job queue server and passes its serialized instance as a parameter. And then the last one is called public final function run. This is actually going to be the method that's run on the queue server, and it executes the _execute function, not the execute function. The reason for this is that the execute function, we don't want to actually have this running on the front end. So when we want to actually execute something, we call the execute method, which doesn't actually execute it, it just passes it off to the queue server. So we can take a look at how this actually is implemented in my code here. We have our _execute here, and you note that we have a comment here saying the test should be run via run, not execute. That's because this execute here, all it does is it creates the individual HTTP job based off of the URL, and then passes an object that's been serialized and base64 encoded, so you don't have any 8-bit characters in there. And then what we do is we have our run method defined here, which will call the _execute method that's been defined in our individual task that we want to run, which is what we see right here, _execute being defined. So this is the functionality that will be run. So I actually do have an example of this. If I go to my content controller, it's not the same. It's not the same one that we had there, but we see here our bit.ly task, which will go out and get your bit.ly URL for an individual URL. We create a new instance of it, and we simply call execute. At this point, the execute is called, and it's going to pass this off to the job queue server for actual execution. But it's not going to be executed here. So the question, though, is how do you actually test this? And the way we do that is by building out an individual test. So I've got a couple of tests here. We've got a task, I got a Twitter search test here. And what you'll see here is that I, first of all, delete all the data that I have, and then I call my new admin task Twitter search, and I do a search for Zend, and I run it using an instance of Zend application that I've got defined there. And so basically what I do then is after I've run it, because this run is actually going to be built, is the place where the functionality is actually executed, once it's returned, this is actually a blocking operation. So once it's returned, I can test to see whether or not the fetch all actually returns something more than 0. If it returns only 0, then we know that nothing has happened, because if we go back to our Twitter search test, we see that if there's any search results, they're going to be saved into the database. So it's a little bit of an assumption, but it does work pretty well. So if I want to run it, we see that it implements a PHP unit framework test case. So I click on run as, go to PHP unit test. Hope that it works for a live demonstration. And wait for it. And of course we're waiting for it because it is doing an HTTP request over to Twitter, and we see that the test execute is actually run. Now, at this point, I mean, you've basically shown that the test is properly being run, it's properly passed. The only thing that we need to do at this point is actually implement it so we can queue this up in the wild. I'm not going to go into any great detail in that here, but just to show you how that actually occurs, I have a queue module, and we get all the current parameters. We check to see if there's a parameter called obj. If so, we decode it and unserialize it. Check to see if it's an instance of task abstract. If so, then we call that run, the exact same run that we called in our test right here. So where to go from here? There's a couple of places. First of all, you can go to Zend.com and get a free trial of Zend Server, which has the job queue in there. You can also go to Facebook and see us at Zend Technologies, or to twitter.com/Zend, or you can also follow me on Twitter at kpschrade, or go to eschrade.com for much more fascinating information just like what you saw right now.